Okay. Diggs, what are you up to? All right. Now that we've got things ironed out in terms of code, let's start to make it like a more finalized diagram of things. Okay, so we can start let's see. This is close here. Okay. Let's start in the controller. Events controller. Metric event controller. Okay. So this takes this create metric event DTO in, which is this. Okay. So that looks right. Let's figure out exactly how we want to represent this. This really comes into event. Producer. And what it sends over is this, which is a create metric event DTO. And that sends that to what we would call the metric events controller. That lurking and learning. Welcome. Always welcome. So this guy does two things. One of two things. It either forwards the metric event to dev if it's not authenticated and we're in prod, or it sends the event to Kinesis, the Kinesis data stream. So trying to clean things up in terms of diagrams, documentation, etc. for this feature. So we're going to have events controller. Let's not worry about this for right this second because I don't know that that's accurate anymore. Okay. So we got this thing, and then this is going to go one of two different places. Maybe I'll treat this as like going off down here. This is going to go to let's move this out. This is a whole new phase. This is not part of this. Okay. And this thing actually is, I don't know how we want to represent this visually, but this is really more something like this. I need to add a dot in there. There's got to be a way to do this. Edit line. Okay. This is forward to dev environment. Get rid of this. Let's get rid of this. Okay. Make this much smaller. Okay. We know what this is. This is a lambda at this point. This is the metric event consumer. Lambda. Okay. It's looking pretty good. Now, just to verify data representations. So we go from this event source payload and occurred at into our metric event controller host endpoint. That thing looks at that and checks and the authentication header and figures out the authentication and then verifies the user's authenticated. If they are, it gets their project ID, and then if they're not authenticated, then it forwards to the development environment. If it is authenticated, then it sends that event on to the Kinesis stream. And then that Kinesis stream sends it off to Kinesis Firehose stream, which saves the raw events, buffers and saves the raw events in S3 as Parquet files, which we are eventually, after we launch this, going to add an Athena database on top of that, or use the Parquet files and add the Athena SQL engine on top of those Parquet files, and then build some sort of Lambda or something so we can query Athena to replay events into the Kinesis stream when we need to. And then we have metric consumer over here, which we built, and that consumes those events, normalizes them, finds or creates event users for them, and find or create event users for them. And then we have create if doesn't exist in OpenSearch. And then we have save raw event. Okay. all of that's looking spicy, looking good. Okay, so we need to figure out our data formats. So before we had this create metric event payload, but now we are going to, now we just have, we clean things up a bit. We send over all of this stuff, and now what we have is between us and Kinesis stream. We have this Kinesis raw metric event, which has event source project ID occurred at event source. We can copy this as a starter, but so event source project ID occurred at and payload. Payload is it's a string, but it's expected to be a JSON. And then the entire thing is JSON and base64 encoded. This is the Kinesis raw metric event. Okay. I think that's all we really care about actually from that now that we've cleaned things up. Don't need to worry about that. So it comes in and then then we break off into our event processing diagram, which we should just have as a separate diagram. Yo, Osminos. Nice. Glad you like the tunes. We got a little bit of dubstep going right now. Just trying to clean things up so we can get this thing deployed to dev and test it in dev. I've been testing it locally, but the actual like controller piece I haven't been testing locally. So that piece we're just gonna roll with it to dev and test it in our dev environment. Make sure it's good there. Hopefully it works and it's not disruptive to the rest of the team. If it is broken, then we can roll it back, or depending on what the issue is, we can fix it. But before we do that, I'm just trying to clean up the diagrams to make the diagrams accurate with what we have. How are we on automated tests? So we have all of the metric event consumer stuff that is not dealing with integration with the database or OpenSearch is tested with unit tests. In terms of how I tested the Postgres and the OpenSearch, was I did like pseudo automated tests for validating that integration test, which was like I have a command line tool that uses the same code that I would change the inputs and run. And that is, idealistically, I would have set up integration testing with Postgres specifically. OpenSearch would have been a little bit harder. But because the tight timeline and the fact that it wasn't already set up with one, like I didn't have time to dig in and set up an entire integration test suite for this. So that would have been nice, but sadly didn't have time to get that done in this project. But we made steps forward because we added unit test coverage for all of this stuff as we were cleaning things up. So that's good. And then this, I actually, on the metric event controller side, there was a useless test that existed for that, so I just nuked that because I reworked the entire thing to simplify it drastically. And so that piece is just talking to the Kinesis stream. And so there's no test coverage around this piece right here connecting to the Kinesis stream. There's not a whole lot going on in here anymore though. Like it literally just takes a payload in and then like sends the payload off. So like there's very little processing happening in here anymore. All of the processing is generally happening inside our metric event consumer, where it's doing all of the normalization of the events and the standardization of the events from the different sources and packaging those and storing them in OpenSearch and Postgres. So this now no longer does like hardly anything, basically. Like it literally checks authentication, and then, you know, if you're not authenticated, it forwards that event onto our dev environment. If you are authenticated, then it lets that event go through to the Kinesis stream. But yeah, and then I just went through and cleaned up these, because that was one of the pieces that I was having to work through, was the data representations. I changed the data representations, not on this side. This side stayed the same because I wanted it to be backwards compatible. But the data representation that goes from the controller to the Kinesis stream is something that I had to define. And there was like 3 or 4 different data representations that were involved in the old implementation. And so I cleaned all of that up and standardized on one data representation to go from the controller to the Kinesis stream now. And that's where this left half of this diagram went, was into that diagram, which makes a lot of sense. And this is kind of starting to be the next diagram, which is the diagram for the actual metric event consumer. So I think that's the next thing that makes sense to square away, is the actual metric event consumer diagram. Let's make this extra large. that what I was doing? Oh no, just that. Alright. So we're gonna have this metric event consumer thing. This is, well, we get to talk about all the stuff we were talking about before Aspinos. And you can see kind of how I ended up breaking things apart. This was, what was this? Oh, this was controller's repository boundary discussion that we had. Let's move this over off to the side somewhere. It's kind of tangential to this thing. I should make a post about this. I have this conversation that we had, Asminos. I have that conversation with people on the regular, I feel like. It's probably worth making a post about it. Why did that not highlight? There we go. Maybe I don't want to start with this as the example. Maybe I do. I blog a decent okay amount. I mean, I'm not as regular as I would like to be, but yeah, if you go to my site, if you go to drew-dupont.com, you can see my posts there. Quite a few posts, but talk about like all different kinds of stuff I'm working on, inversion of control, patch stack, how to make code reusable, etc., etc., etc. Lots of stuff. Lots of Git stuff, Swift UI stuff, backend web framework explorations that I've done, all kinds of stuff. Yeah, there's all kinds of good stuff. And then my keyboard situation is up here as well, with pictures and everything. So if you want, curious about the process, you can see the build and photos of the build and everything. But yeah, and then the QMK configuration that I have for the firmware is also up there, so you can see the layout and everything that I use. It's all on GitHub for that one. You can see our event in OpenSearch and Dev. Okay, how are we gonna do this diagram though? I don't have a picture in my head of what this should look like exactly. We could do a layered architecture diagram. Oh yeah, I've built many keyboards. I probably have built like, I don't know, 12 to 15 keyboards, somewhere around there, throughout my career. But the Dactyl Manuform is my favorite. Yeah. I know Prime will tell you that, you know, you go Advantage 360, but I don't like the Advantage 360 thumb clusters. My fingers are relatively short. Like, I'm not like a pianist who has long fingers and can stretch really far. And so I find the thumb clusters on the Advantage 360 basically useless. I only get to use like the main like keys on the thumb. So all the rest of the thumb clusters are useless for me. Where the Dactyl Manuform, the thumb clusters are completely usable for the whole thumb cluster. So, and it just feels more natural with the shape to actually use the thumb clusters on the Dactyl Manuform. So, Okay, so what are we going to do? We're going to do a layered architecture diagram. Let's start with that and see where things go, I guess. I don't know why I got this straggler thing. Okay. Alright, so let's look at the Lambda project. Okay. So, looking at the Lambda project top level, this is what we see. We see configs, db, metrics db, and then handler and other top level files. Okay, so let's just start with configs, db, metrics db. So we have configs, db, metrics db. Nice, we already got these. All right. So those are our 3 top levels, and then we have another top level, which is the actual program that is utilizing those, which is some other top level here. Okay. Okay, cool. So we have metrics DB. Metrics DB is about interacting with OpenSearch. DB is about interacting with Postgres. Okay, configs is about interacting with the environment, except we own both of these. And then down here we have process.env, which is what that one's really interacting with, that's out of our boundaries. So it looks something like this. Okay. Okay, then we have what am I thinking? So that's got the handler. Okay, so that's really got 3 things in it. That's got the handler, the create, finder create, and the raw metric parsing. So let's just make that another layer. Actually, let's do this. So that has raw metric parsing concern. It has the raw metric handler, and finder create. So let's do find or create event user. We have raw metric event parsing. We have the top level handler, raw metric event parsing, finder create, and handler. Handler's like a handler. Raw metric event parsing. This has nothing to do with either of those. I don't want to represent this. Okay, so we got our handler. Okay. There we go. Okay. This is some future thing for this that we will add in later. Okay. Now we just got to bring some layer definition into this thing. So this is I want to describe this. This is domain-oriented actually, the more I think about this, we actually need to separate these. We need another layer. Okay, so this is generic utility for interfacing with process and in safe, in a controlled and safe way. Okay. These are formalized interfaces for interacting with PostgreSQL and OpenSearch. Support the needs of the domain. Okay. domain logic. External dependencies. Okay. I feel better about that. What about this stuff? Can go. This can go. Okay. Looking good. Looking good. Let's just center this a little bit. Okay, let's copy that. Let's paste that over here in this other one. What are we going to title this thing? Explanation of repositories and controllers' responsibilities. Whatever, renames it. Okay. Then we can get rid of this. Okay. Okay, let's move this. We're going to create a copy of it down here. And this is going to be future setup, which is going to be this. I think it's like, yeah, this is. We're gonna have the same thing actually. We just need to change the names of things. This is some lambda. This is some metric event producer. This we're gonna have in here. Just mental maps that you're doing for your own reference. Give the title of each diagram and explain the purpose. Not familiar with these formats. Yes. Sure. Let me finish this real quick, just this future one, and then I'll explain. Sure. This guy needs to do that, and then and then we're gonna have him talk to this guy, and I guess we can move this over here and this here. And this will go away. And to make this prettier, we can drag this over here. Okay. Okay. And then this responses to the post metrics events endpoint takes a long time. This is because let's say this is what the planned future state of the world of the metric event ingest will look like once we set up a separate AWS API gateway endpoint tied to a Lambda function as the controller action. The benefit of this is that it is completely separated from the API that supports the mobile/web applications, which will allow us to keep metric ingest going without interruptions. Okay. So okay, so when I started this project, I created this just to make sure I had an understanding of what the original setup was and why, you know, we wanted to make this change in the first place. And so originally we had this metric events controller with this metric events endpoint that you could post to, and that would go to a factory server. It would enqueue a job in a factory server, and then there's a factory worker that would pick up that job and execute it to process it. That job would then do a few things. One, it would save the raw event to Postgres to persist it so that we could process it later on if we needed to again. And two, it would find or create an event user. Okay. And then the third thing it would do would be that it would check in OpenSearch if that event already exists. If it does already exist, then it wouldn't do anything. If it doesn't exist, then it would create it inside of OpenSearch. Okay? This had problems because factory server was having problems, and there was apparently no straightforward, easy ways to resolve those problems. And it had scaling limitations as well. So that's where we shifted to a less scalable solution as a short-term solution, just as a stopgap, so that we could get rid of factory server and its problems. And the way we did that was just having this controller action execute the factory job itself directly, right? Which means that every time this post metrics events endpoint is hit, that takes a while, right? All this checking that it does, talking to Postgres and OpenSearch, all of that had to happen as part of this, right? So it would just block, dealing that request for however long that took, okay? Whereas in this original one, the only blocking that it did was the cost of enqueuing the job into factory, and then the processing would happen on the back end, right? So we knew this is less than ideal, but at least resolved the issues that we were having with factory by eliminating factory. So then we planned this, which was the work that I'm wrapping up right now, and we can get rid of this now, which is we wanted to add a Kinesis stream in line here so that we could have the controller action do very little and pay very little cost and just enqueue the events into the Kinesis stream, and then have the Kinesis stream and all the stuff after the Kinesis stream do the processing, right? And so then I made this diagram to help myself understand what that new world was supposed to look like, and how we wanted it to work. And I tacked in additional pieces of information that are useful as I was going through and refactoring all of these things. Like, okay, here's the data structure representation of the payload that goes in here, right? And I know I don't want to change that because I'm trying to make this a backwards compatible change in terms of how the metric event producers interact with our endpoint right now. So, and then I made note about, okay, well, like, what's the structure of data that we need to send to Kinesis now? This guy has to do that manipulation to put that form of data and manage wrapping it into this form of data. And then that we're going to have the Kinesis stream, and then I split some of those concerns. So like the save raw event thing, before that was part of a worker. Now we have this separate Kinesis Firehose stream. So every event that comes into the Kinesis stream gets sent over to this Kinesis Firehose stream, and that Firehose stream buffers all those events and saves them into Parquet files in S3 for disaster recovery, right? And the whole point of that is so that in the next phase of work, which I'm going to do after we get this out, the next phase of work is going to be to wrap to put an Athena SQL engine in front of those Parquet files so that we can run SQL queries against those Parquet files. And that will then allow me to build a Lambda script that will be able to query those metric events, those raw metric events, and replay them in the Kinesis stream in the case of like something goes wrong and we need to replay some events. But this loop allows us to not lose events, ideally, right? And then the other portions of the logic, which was the like find or create the event user and the create if it does not exist inside of OpenSearch, that is handled now by this metric event consumer Lambda, which is what you were, watching me work on before us, and what we were talking about with the database and the controllers and the separation of those and what their responsibilities were. And so this is just a diagram to represent all the pieces and the interactions at a high level. And this started as a tool just for me, but what I've found is that over time, like, it's worth the extra 10 minutes or whatever to true these up, because then they end up being useful to the whole team. When somebody else has to jump into this section of the code base, they can have a diagram to understand how things are supposed to work and how they do it. And understand the various pieces that are involved and connected. So then there's, so the way I look at this is like this higher level, how the system works. So this is almost like a systems level architecture diagram, except that I sprinkle in specific tidbits of data, like the structures of data here. And having those structures of data is just super useful when you're trying to refactor systems and you're trying to maintain certain interfaces. So like this one, I know I have to abide by this. This one I got to change and control. In fact, there was like 3 or 4 different data formats in here that I was able to collapse down to just this one. now in this new architecture. And then because that's in the middle, like, it's a refactor in terms of the system because I'm holding this boundary in this interface, but I'm able to change how this inner portion works. And then the interfaces for the Postgres event user and for the OpenSearch, I kept those interfaces the same, right? So that's kind of why I sprinkle in things like this into the diagrams. Now this diagram here is generally referred to as like a layered architecture diagram, and the idea is to separate. You're separating by like abstraction levels generally, or you're separating by like responsibilities or ownership or things like that when you're doing a layered architecture. And so when you look at this is a layered architecture diagram of the metric event consumer, which is just this piece of the puzzle here in the systems architecture. And so if we look at this top down, we can see the various layers of this application's architecture. We can see that it's got a handler, which is what Lambda calls. And we can see that part of that is that it does raw metric parsing, which is really like normalization of events. And then it also does this find or create event user, which is that crazy function that still needs to get refactored and cleaned up. But those are kind of live at the same level of like, this is the core domain logic for this problem space. And then we have this other layer, which is like, we have configs that are how we interact with the environment to fetch configuration data. That has a dependency of env, and env is a generic utility, right? Like, so this is just a generic utility that we wrote as part of this application to facilitate interfacing with process.env in a safe way, right? And so this has technically nothing to do with like this stuff up here other than that we are using it. But like, it's generic enough we could extract it into its own library right now, for example, right? Similarly, here you could inverted I2 and I3. I2 and I3. I'm not sure what you mean by I2 and I3. Layer 2 and layer 3? Which direction are you counting from? Here, let's label them. So like, let's call this layer 1. Okay, so we have layers 1, 2, 3, 4, and 5 now. Layer 5 we don't control at all. These are like external dependencies that we don't control at all. So like the Postgres package, the OpenSearch package, and process.env. Right? So layers 3 and 4, layers 4 is totally generic. Like, we could just extract that and that could be useful as a library or the beginnings of a library right now. Layer 3 has the DB and metrics DB. Both of those are written as generic libraries. So they have no knowledge, meaning they have no knowledge of the layers above them. And only things they have knowledge of is stuff defined inside them or the dependencies that they interact with, which are PG and OpenSearch, right? So we could extract these and use these as a library in another program, is what that's saying. Now, however, these have specific sets of functionality that exist to support the layer above them. It's not knowledgeable about the layer above them, but it has specific things to support the layer above them, right? So, for instance, like in Postgres, the thing we store in Postgres is an event user, right? So if we go look at that DB, in DB we have this find event user by ID, find event user by anonymous, find update event user last seen, update event user anonymous ID and last seen, right? And we have this concept of an event user in the database, okay? So those functions are functions that exist within the world of our database and our database representation, but they don't necessarily exist for the purpose of our domain problem-solving space for this application. So it's generic in that sense, but it's not as generic. It's not as generic as, say, the end thing, right? Where the end thing is just like how to interact with environments. In fact, the end thing is closer to, if you want to think about it, it's closer to the genericness of like PG and OpenSearch library. Except that it adds safety on top of it, basically. And then configs is closer to the domain up here as a layer because this has more knowledge, right? This is not generic. It uses this generic env library that we wrote, but it is not generic because it has knowledge about the configurations that it's pulling in specifically for this thing, right? So, but it's separated as a layer because this is a dependency of this guy, and this is focused on a different separation of concerns. Its concern is how do I fetch the necessary configurations from the environment, versus this guy's concern is how do I do the core business logic. Does that help us, Munis? The order if the inner layers. We say that layer 3 can be just above layer 2. How do I describe it? Okay, so layer 3 would live, you could merge layers 2 and layer 3 together if the DB module and the metrics DB module had knowledge of the business models that this guy defines. They are more generic than this guy is because they have less knowledge of the domain. That's why they're separated and they're lower in the layers. because they have less knowledge about the domain than this guy does. That's why I have them separated. If if you think about like classically a repository pattern, in applications is often used to facilitate the mapping between the database representation of something and the business model representation of something, right? And so oftentimes the idea with your repository is that you can interface with it with business model concepts, and it handles the translation and mapping to whatever that might look like in the database. So that could be like you give it a single object from the business model world, and behind the scenes it's interacting with 3 or 4 different tables inside a relational database or inside of a NoSQL database. So the idea is that it's doing that translation of those business models. If these modules were repositories that had that knowledge of those business models, then yes, they would have to move up a layer to be closer to the core domain. But because these modules are not repositories, they're effectively utilities that have no knowledge of the layer above. They could be extracted and used in a separate application that needs to interact with the same database or the same metrics database. So that's the benefit of doing it the way I did it, is that they're more generic, so they could be extracted and used in other applications to facilitate interacting with these databases as they're written now. If I made them a repository where they have intrinsic knowledge of the business model that is part of the core domain logic here, then I would not be able to extract them as independent libraries, because I would have to also extract that business model concept. And the business model for this domain does not necessarily equate to what the business model should be in another problem space, another domain that needs to talk to the same database. So that's why I didn't do the repository pattern here, was so that I could keep it generic and keep it so that I could extract it if I needed to in the future. But yeah, that's the distinction between layer 2 and layer 3. And so you definitely wouldn't want to flip 2 and 3 right now, because configs are more knowledgeable about the domain. But yeah, and then future setup, this last diagram, was more a reminder for myself, so that, because what's happening is I'm going to finish this piece that we're working on and cleaning up and get that deployed and working, and then my time on this project is going to be cut in half. I'm going to be working like half time on this project, half time on another project, which means I need notes and references to keep things on track, so I don't have to like rework through all the code to figure out what I'm doing exactly. And so this diagram's a variant of the system diagram up here, which is the current phase of this, which is planned, which this is kind of like 3 phases. And so I'm on phase 1 right now. Phase 2 will be adding the Athena layer and the Lambda for disaster recovery, which will be phase 2. And then phase 3 is really this guy. And phase 3 is this future setup where we're going to replace and extract this logic into a separate AWS API gateway and Lambda over here, instead of being part of the same API that serves our mobile and web app. And that just gives us that flexibility of being like, hey, we want to do rapid releases, or let's say we have to take down the API for some emergency or something to facilitate something with the mobile or web apps. Like, we can do that without negatively impacting metric ingest, right? So meanwhile, if we have this setup, we can just keep consuming metrics all the time and processing metrics, and that's a completely separate process where we just ingest metrics data and process it on a regular basis, And then the web app API and mobile app API are completely separated, whereas currently they're combined into one, right? Right now the metrics event endpoint is an endpoint inside of the mobile/web API. And so that's what this last version was all about. It's just a reminder of what my plan is and how I'm planning to do it. But again, as I go through that phase, I'll come in here and update it just like I came in and updated these to true them up and make them more accurate, because these diagrams I've found to be invaluable with projects, with various people involved and having to share stuff. And it gives like the conversation that you and I just had, Osminos, about this. Having this artifact here, if nothing else, allows us to have that conversation, or me and somebody else to have that conversation in the future, right? Whereas if this didn't exist at all, they might not realize that there was an architectural choice that was decided to keep this layer more generic and not make it a repository, because we didn't want to have it have knowledge of the business model in this thing, right? So yeah, so for me it's invaluable, but it's also been invaluable experience-wise just having it be on a team with other people. And I will package this as part of the code. So I'll include a snapshot of these as part of the code and a link to this in the README of the project so people can jump over and see it. But yeah, okay, cool. So the diagrams are all trued up. Visualizations are like everything in my mind. Like, I'm just a visual learner, but like I'm also like, I can't just visually see something. It helps, but I need to like visualize it, repeat it, and then do it for things to actually stick. I've tried like what is it called? Mermaid. I've tried Mermaid and a few other things for like embedding diagrams, and I've used a bunch of different tools for creating diagrams that are like created from code where it automatically lays them out. There's certain use cases where that's fine and works really well and makes them easy to manage. Like if I was doing a sequence diagram, there's a really nice Mac app. What is? Do I not have it installed on here? I haven't done it recently. I did change my machine not too long ago, so it's possible. But Mac sequence diagram. Is this it? Yeah, so this is like an example of that on Mac. So this is an example of it on Mac, which is like you write, which is like GraphViz, if you're familiar with GraphViz at all. But basically, like you just write text over here in a certain structure, and it like facilitates sequence diagrams. But it's like GraphViz is like the open source, more generic one that I've used as well. And GraphViz supports a bunch of different like formats and visualizations and stuff. That's useful, but like lately I've been just using Excalidraw a lot. It's nice for me to play around with things in a more flexible way than having those structured things. But if I know I'm producing a specific thing like a sequence diagram, then I'll go to use a tool like that, because sequence diagrams are a very well-defined specific thing. But yeah. Okay, so we got diagrams trued up.